going to be going over some of your homework. We're going to watch some of your videos of your the research, and then we're also going to go over the data collection worksheets. How did the experiment go this weekend, guys? This is the video for the sled dog racing, okay? I watched all your videos on the weekend, and I chose 3 to watch during class, okay? So let's see how Jack.
Hello everybody, my name is Jack. Today I will talk about the technology in a dog sled race. Dog sled use GPS to track their location during the race. So what is GPS? GPS is a system of satellites designed to help navigate on the earth, in the air, and on water. GPS receivers shows where it is. It may also show how fast it is moving, which direction it is going, how high it is, maybe how fast it is going, up or down. It helps the racer find the way to finish the line.
So Jack, you did an amazing job. I can tell that you did your research. You also have something written down, so you have something to read off of, which can really help while doing a presentation. Your voice was nice and clear. And overall, I liked, even though I talked about the GPS, you talked about different things about, how it can track your speed, your location, things like this. So Jack, I think you did a really good job. Does anyone have any comments about GPS or Jack's presentation? Okay, guys, let's move on. So now we have Milk.
We need the sled and the dog to go faster and far. We need the materials to be light to make the sled go lighter, so the dog can go very faster and far. When the dog gets too cold or too hungry, we force the dog eat food dog, and we force the dog to wear boots and jacket for dogs. And when we get lost, we bring a GPS to get up safe from the dangerous forest. Or sometimes we can get lost. We use the GPS to find our way to get home. Thanks, goodbye, and remember subscribe.
Milk mentioned 3 different technologies. He talked about GPS. He talked about staying warm, so having jackets and booties for the dogs. Yep. And then he mentioned something very interesting. He talked about how they need to make the sled lightweight so it can go faster. Can lighter objects go faster than heavy objects? What do you guys think? Blue Moon.
Yes.
Yeah, I believe so. I think a lighter object is able to go faster. And for these dog sleds, are they using a large amount of force or a small amount of force to race with? Are the dogs? Yeah, it's a very large amount of force. Very good. But if the dog sled is lighter, then they will be able to go faster. Very good. Okay, really good job, Milk. And our final one is going to be Daisy. Daisy also did hers on GPS.
Hi, I'm Daisy, and today I will talk about what technology used in the sled dog race. Sled dogs are very strong dogs, and they wear boots to keep warm. They run fast to finish the race. Sled dogs driver called mashers, and one device called Spot is attached to every masher's sled. It has one button, and that will deploy emergency rescue. It's use GPS technology. Do you know what is GPS? GPS is Global questions. 1. Location. GPS can determining a positioning. 2. Navigation. GPS has getting from one location to another. 3. Mapping. GPS can creating maps of the world. And this is the end of the story of the video. Thank you for watching and listening. Goodbye and see you next time.
So Daisy, that was awesome. I love your whiteboard. The whiteboard is really good. It's really nice to have something in a presentation which the person watching the video can read and see what they're talking about. Her whiteboard has everything about a GPS, what it stands for, and the 3 things we can do with GPS. She also talks about how strong the dogs are, how there's mushers, and overall, it's a really good presentation. Good job, Daisy. Good job, Daisy. And I really like your whiteboard, and I really like your energy. You're so excited while you're presenting. You're so excited when you're presenting. This was probably my favorite presentation. Good job, Daisy. Okay, get out your data collection worksheets, guys. Okay, so what were your experiment results? Who can tell me some of their data? Let me lower everyone's hands. Remember, with our toy car, tape, and a ruler. Raise your hand if you have your data. Pasa's raised his hand. So Pasa, what was your data?
The first one is a little horse, and the car rolled 10 centimeters.
So it rolled 10 centimeters. Was that with a little force?
Yeah,
And then how much with a small force?
50 centimeters.
Okay, and then a medium force?
Medium force, it goes 30 meters. 30 centimeters.
Okay, and then the large force?
35 centimeters.
Very cool. So with the more force, was your car traveling further or less far with more force?
Farther.
Further, yeah. And how about this? I have another question for you. Do you think the car was traveling faster or slower? Was it traveling faster or slower the harder you pushed it?
Faster.
Okay, very cool. Let's see what else people got. Good job, Pasta. Does anyone else have their data in front of them? Raise your hand if you have your data. Okay, Kim, did you do the experiment?
Yes.
What happened? So you pushed your toy car with a little force. What happened when you pushed the car with a little force?
It cannot go far.
It cannot go far. And what happens when you push it with a lot of force? Did it go to like the other side of the room? Where did it go?
Other side of the room.
The other side of the room. Okay. So what type of floor did you use, Kim? What was the floor? Was it made out of wood? Was it made out of carpet?
Plastic.
Plastic. Okay. And is it pretty smooth or is it rough?
Smooth.
Smooth. Very cool. Very cool, Kim. Thank you for sharing. Okay, Sam, what are some things you observed during the experiment? What happened during your experiment?
I used type of floor is a wooden floor.
A wooden floor. And is your wooden floor pretty smooth?
Yeah.
Yeah.
And even light force can go 16 centimeter.
Whoa, so your car went really far. Okay. And how about with the large one? How about with the large force? How far did it go with the large force?
29 centimeter.
29 centimeters. Whoa, okay. Is there anything else cool that happened during your experiment? Did you try to do this outside in the grass or on a different surface?
And no, but I think in the grass is a bit rough of dirt and rough moves slower.
Okay. You think rougher floor will make it go slower? That's a very interesting idea. Very good. Thank you, Sam. Taylor, what did you observe?
I observed that my cardboard is not very smooth, so
the car can't go very far and fast. So when I put it slowly, it's go only like 10 centimeters,
Oh, only
not
10.
very far.
Taylor, did you think it traveled faster the more force you used? Would you say it went faster? The
I
car?
think when I push it with a big force, it will go faster.
Very cool. Okay, thank you, Taylor. Okay, so these are some discussion questions we had for your conclusion. Who can tell me, how did force affect distance traveled? Lisa, we haven't heard from Lisa yet. Do large forces cause things to travel further or shorter?
Further.
Further. Okay, so how did force? So what we can write, the more force we used to push the car, the further the car would travel. So that's our sentence. The more force we use to push the car, the further the car would travel. And then let's look at our next question. What was the furthest distance your car traveled? Raise your hand if you think you had one of the biggest numbers. Look, how far did your car travel?
You are saying in the
With
what
the
kind
hardest
of?
push, how far did it travel?
33 centimeters.
Okay, so I can retype with the largest force. My car traveled 33 centimeters. Okay.
Yes.
And then with the smallest
No,
amount
the biggest. With the
of-
biggest.
I know that was the biggest. With the largest force, my car traveled 33 centimeters. With the smallest amount of force, my car traveled. How far did it travel?
1 centimeters.
1 centimeter. Traveled 1 cent. Oh, okay. With the largest force, my car traveled 33 centimeters. With the smallest amount of force, my car traveled 1 centimeter.
Mr. Connor.
My result is amount of force of my third car if using a light force is go about 3 centimeters.
Okay.
If I go with small force, I go with 59 centimeters. A medium force is 138 centimeters, and large force is 358 centimeters.
Whoa, your car went really far. Was your car traveling really fast with the largest force? What type
So-
of floor we're using?
I'm using my wood floor.
A wooden floor. Okay, so we can answer our final discussion question. Do you think the type of floor you used changed the distance traveled? Wait 1 second, guys. Yes, the smoother floor made my car travel faster and the car went further. Okay, guys, so we're gonna have to move on, but we're gonna still talk about our cars, okay? So no worries. I just want to talk to you guys about smooth surfaces versus a rough surface. Let's have Cherry. Can you give me an example of a smooth surface?
It can be the wood floor.
A wooden floor. Perfect. Thank you, Cherry. Okay, Moon. What's another smooth surface?
Table.
A table. And what's your table made out of?
Glass.
Glass. Oh, glass is very smooth. How about Ben 10? What's another smooth surface?
My smooth surface is made out of stone.
Stone. Okay, some stones have smooth surface. Very cool. Yes, Ben 10. I got some smooth surfaces on the screen. We have the wooden floor. Sophia, what is this a picture of?
I guess it is something in the car.
I think you're right. I think this is a car and it's very smooth. If you want to know a smooth surface between a rough surface and smooth surfaces are really good at reflecting light. They're really good at light bouncing off of them. If you look at all 3 pictures, they have a lot of light that is bouncing off of them. Who knows some rough surfaces? What is a rough surface? Sam, what is a rough surface?
Rough surface is opposite of smooth.
Yeah, can you give me an
rocky
example?
road.
A rocky road. Okay, that's good. That's one of the first things I chose. A rocky road. Look at that. It's a very rocky road. So I have this wood. So this is wooden floor that is not smooth. This wooden floor is rough. And then of course, grass can also be considered a rough surface. And why does this matter? Why does your toy car or the football you kick eventually stop? Why does it not go forever? If we put a force on something, why does it not travel forever? Yeah, the answer is friction. The answer is friction. But let's get to the point, guys. So what causes the toy car to stop? It is friction. It is friction. I want everyone, I'm going to show you guys friction really quick. Put your two hands together, and I want you guys to rub your hands up and down really fast as you can, as fast as you can. Oh, we have Moon. What happened, Moon?
It's hotter.
It got hotter. If you rub your hands really fast, they get really, really hot. No, it's because of friction. Friction is two surfaces rubbing on each other. Let me show you guys an example. Okay, so we have your toy car on a smooth surface. Do you guys think a smooth surface has a lot of friction or very little friction?
Please.
It is little. Very good. And I'm going to make the arrow kind of small. On the smooth surface, this force or friction is going in the opposite direction. And it's a small force. It's a small force. So your car travels really far on a smooth surface. But eventually, it will stop because of friction. Because of friction. Not only the friction on the floor, but there's also friction with the tires spinning around an axle. There's friction all over the place, slowing down the car. That's the only reason the car stops. If there was zero friction, the car would go on much, much further. Okay? Maybe not forever, but much further. And then we have a rough surface. Look at that ground. With the rough surface, the friction is much larger. So if you use a large force, the friction also has a very large force. So your car would travel not as far on a rough surface. This is why friction is important. Is what force is acting on this tablet?
It's gravity.
Okay. It is gravity, but make sure you're not unmuting. I will call on you. But friction is holding it up. Your hand has friction or grip, and you can hold certain objects. The friction is what's stopping the tablet from falling to the ground. You're also using a force upward with your hand. So there's friction. If these are equal, the tablet will not move. If these are not equal, the tablet might fall down to the ground, or you might throw it up in the sky. Okay, guys, that's enough for friction. Let's go over your homework. And this is our review slide. What did we learn today? How did the strength of the force affect how far the car would go? The stronger the force, the further the car traveled. Yes, the more force you push an object, the faster it will travel. But I think everyone did a good job coming to that conclusion. Your homework for tonight is your lesson check and your lesson roundup. You guys did a great job today. I enjoyed watching all your videos, and I'm glad the experiment went well at home.